Alright, hi everyone. We're going to do a video on solids, liquids and gases, and the topics that we're going to have a look at are these. So we're going to have a talk about the equation and a couple of examples of type of question you can get to calculate the density of a substance. We're also going to be talking about how you can measure the volume of an irregular solid using a little bit of a really simple equipment. Then we'll talk about the equation and a couple of examples of ways of working out the pressure exerted by a gas or a force. Then there is the pressure exerted by a liquid, here fluid pressure, and the equation that goes with it. Then we'll talk a little bit about the changes of state in materials, so as you go from solid to liquid and to a gas, how that happens, or what happens to the temperature of a substance as those changes of state take place. Then we'll talk briefly about Brownian motion, then about the Kelvin temperature scale, and finally a little bit about the pressure law and the Boyle's law. Pressure law is the fact that the pressure is proportional to temperature in an ideal gas, and Boyle's law is that it's inversely proportional to volume. I will talk about what those mean, and you see they're quite intuitive, both of them, and the equations that you use to solve questions with them are quite simple, yeah, don't worry too much about those, it'll be okay. What else? As you know, well, hopefully by now you should have found out, revision is something that is a very active process, and that means that you should go away and do lots of practice questions in this topic after you see the video. You shouldn't just expect this to sink in and then that be all of it, but hopefully this will be a very good thing to rely on whenever you need a little bit of a recap. You can come back and watch this. I recommend you take notes as you go along on anything that you don't have notes yet. And so let's get started then. So the first idea is density. So what do we say about density? Okay, so the symbol for density you should be able to recognize is a kind of P that's sideways, okay, and it's written rho. That's a symbol for density, and the equation for density, you can remember it with the triangle. I'm just going to give you the normal equation which defines the idea of density first, and then I'll give you the triangle. So density is equal to mass per unit volume, and the triangle would then look like this. Well, it's not very big. Would have the mass on top and the rho and v at the bottom, and it doesn't matter what order you put them in, because when you multiply two things it doesn't much matter what the order is. 3 times 4 is 12, and 4 times 3 is also 12, so it doesn't really matter very much at all, the order of the ones at the bottom. But we usually write the equation as so I'll put the rho on the left, not that it matters much. Okay, so let's translate this into words first. So according to this, we have that the density of something is the mass per unit volume. Okay, so the units of density can be the most popular, the ones that you'll be asked to leave your answers in, depending on what the question gives you, will be, well, for mass it's kilograms, right? For unit volume is meters cubed. But sometimes the questions give you smaller substances, smaller quantities of substances, so they give you stuff in grams per centimeter cubed. So either one of those two you can leave your answers in, but I recommend if the question gives it to you in kilograms, you do it in kilograms per meter cubed. And if the question gives you the stuff in grams, you do it in grams per centimeter cubed, unless they specifically ask you to do otherwise. Okay. So this is a word equation that basically translates what that equation says, but if we set it in words, what the meaning of density actually is, the meaning, it would have to be something like the mass of 1 meter cubed or 1 centimeter cubed of stuff. And what we mean by stuff would be, for example, well, three things. It would be either gases or liquids or solids. Okay, all of these three have a particular amount of mass that 1 meter cubed would have. So depending on the configuration of how if you've compressed the gas or the liquid, or the solid is melted into a liquid, or what's happening, the density of that particular sample of stuff will change. And obviously different materials have different densities, so it's not the same to have 1 meter cubed of gold than to have 1 meter cubed of polystyrene or whatever. They don't have the same mass. So that idea is expressed by the concept of density, and it's a really important one in physics. Also, when you're going to decide if something floats or not, the relative density of the thing you're trying to make float compared with the density of the liquid in which it's going to float, that's what really is going to tell you whether it's going to float or not. Okay, let's do an example of a question with density. Question could say something like the density of aluminium is 2,700 kilograms per meter cubed. Hopefully that doesn't strike you as too strange. 2,000, that's like 2.7 tons for 1 meter cubed of pure aluminium. So if you imagine 1 meter cubed of pure metal, then you wouldn't be able to lift it, right? So that's how much it would, well, that would be its mass. What is the mass of, I'm not going to write it all up, but what is the mass of 0.2 meters cubed of aluminium? So then you write down the equation. They're asking us for the mass. So we look at our triangle. So mass is equal to, the calculations in a different color just for that. Why not? Mass is equal to rho times V. Rho is the density, and here they're giving us the density in the appropriate units, in kilograms per meter cubed, so we can just write 2,700, and that's for every meter cubed. But here we don't have a whole meter cubed, we have 0.2 meters cubed, so we multiply those two together, and if you try that in your calculator, you should get 540 kilograms. And we look at the number originally and we say, okay, so that's 1 whole meter cubed for 2,700 kilos, and this is a fifth of it, and it's 540, so 0.2 is a fifth of 1, so that makes sense that that's roughly a fifth of that, and you can check. But always when you write an answer, look at the question and see whether it makes sense with respect to the numbers that you have, and so if you get a ludicrous answer, you'll be able to spot it and correct it. So if we got here half a kilogram, then it wouldn't make sense, if that's 1/5 of 1 weighs that much. Right, so hopefully that makes sense. The question could say a different thing. It could say the other way around. It could say, well, 0.2 meters cubed of aluminium have a mass of 540 kilos. find the density of aluminium. The equation could say that perfectly, and then you would have to do the equation differently. Well, density is equal to mass small m over big V, always V, and the mass is 540, and the volume is already in meters cubed, 0.2, and that will give you the original density. If you do this in a calculator, you get 2,700 back, which you should. Density of aluminium is the density of aluminium. It doesn't matter how much of it you have, unless you start melting it and doing weird things to it. But when it's a normal temperature, density of aluminium is a number that you can look up in a table, and it's a standard. Same thing with other materials at room temperature. Okay, so that's a few ideas about density. And the second thing that I wanted to talk about was the measuring of the volumes of irregular solids. So this is related also with density a little bit, but we'll talk maybe about that relationship in a different place. But here I wanted to talk about how do you use a little bit of simple equipment to measure the volume of an irregular solid, right? So a regular solid, the volume is easy to measure. For example, if I have a cube like this and I know the length of each side, then I can, what would the other side be? Not that one, this one. Of those three sides, then, well, if this one has a length of L and that's got B and this has got W or whatever, then the volume of that would be just one length times the other times the other. The three lengths together would give me the volume. If they were all 2 meters cubed, then that would be 2 times 2 times 2, right? And the volume would then be 8 meters cubed if each side of these were 2 meters cubed. That would be easy to calculate. It's a regular object, but sometimes the objects, or in most cases in reality, the objects are not regular. They look like something like this. Imagine that was solid somehow, and if you have something of this shape, whatever that is, and you want to imagine those as contour lines, so it looks like a bit of a weird object, and you want to know the volume of that, then how do you do it? Well, you need to use a trick that Archimedes discovered, and the reason that gave him an excuse to shout Eureka, and that had to do with this. You need something called a displacement can, which is an interesting idea and very clever. In a displacement can, basically you have something like that, and here you have the level of the liquid, that level just at the edge, and here you can have an accurate measuring cylinder. For example, normally they're thin ones, the ones that measure quite accurately, they're quite thin, so that a very small change in liquid will have a large change in the height, so you can distinguish the level on the markings. So that's your measuring cylinder, so I'm going to label it measuring cylinder. This one is the displacement can. Displacement can. So what happens? Well, you get the object that you want to investigate for whose volume you want, and you put it in here. You put your object in there, and it doesn't matter how irregular it is. If this water is here at the surface and the edge, when you put this in, the water, exactly the same amount of volume of the solid that you're putting in, is going to be displaced, meaning that it's going to be pushed. It can't occupy that space anymore. It can't occupy, you know, before the water was here, and now it has to give way for the object that you're putting in, so it gets out of the way. And in doing so, what happens is that since this is at the very edge, the water that you're interested in falls into here, and then you can measure the volume of water in the measuring cylinder, and you now have a very accurate amount for the volume of the solid that you just measured. Now when you take this out of there, just out of interest, you'll see that the level of water falls down to like here, and that difference in volume is what's gone into the other place, and that's how much the level rose when you put the solid in. Hopefully that makes sense. And if they ask you in a paper to describe a method of measuring the volume of an irregular solid, then you can use this experiment, no problem. And I always say the keywords here are that the solid displaces its own volume of liquid. Okay, so the volume that the solid has, that's how much liquid will be displaced, and that principle is what allows you to calculate the solid of the volume of the thing. Okay, so that we're 15 minutes now, and YouTube allows us to upload longer videos, but they get a bit tedious if you make them too long, so I'm going to chop this up now and go to the second idea on the next video. The second idea we're going to talk about, so we've done this one and this one, and so we're next going to talk about pressure, fluid pressure, and if we have time, changes of state. Alright, so this whole thing should be about 4 videos in length.